Okay, very good. So I'd like to welcome you to this introductory webinar on hands-on equations. This is Dr. Borenson, the inventor of the system. If you encounter any technical issues, please stay tuned. Usually they are resolved very quickly. Hopefully we won't have any problems. At the end of the webinar, we will be raffling an individual set of hands-on equations. We know from experience that the current school approach to algebra is too abstract and unmitigated disaster for most students. That's from a 1998 national report. Today, 20 years later, far too many students are still introduced to algebra using the same abstract approach. So the goal of hands-on equations and the full-day Making Algebra Child's Play workshop is to demystify the learning of those concepts. The full-day workshop is 6 hours, so today, in 45 minutes, I'm giving you just a taste of what we provide there. The goal is to demystify the learning of algebra so that instead of students feel that they're knocking their heads trying to enter the world of algebra, everything makes sense to them. And the program can be used as early as the 3rd grade with gifted students and with average students beginning in the 4th grade. The 3 major objectives of the system are: 1, to enhance student self-esteem. When you have young students especially that are successful with algebra, they see themselves as having a higher capacity to learn. Another objective is to promote student interest in mathematics. When students are successful with something, they naturally want to do more of it. And as you'll soon see, students are very successful with hands-on equations. And the third objective is to provide students with a solid foundation for later algebraic studies. So we present the concepts concretely, then pictorially, before they learn abstract solutions. The students have certain materials that they use consisting of pawns and cubes and a flat laminated balance. And the teacher has a 3-dimensional scale that has no moving parts and larger pawns and cubes to illustrate the problems. The goal of hands-on equations is to find out the value of the pawn, and that value differs from problem to problem. So let's look at lesson number 1. So let me see if I can share my screen here. Okay. So first of all, in lesson 1, we will begin with a simpler example. We'll say to the student, supposing this side has a weight of 5, and this side has a pawn, and both sides balance. What is the value of the pawn? They'll say 5, and then we'll provide an example like this. And we'll ask them, what's the value of the pawn of each pawn now? And then they'll say 4. So after a couple of examples like that, the students are ready to do an example such as this one. So let's place it up here. We have 2 pawns and a 2 cube equal to 8 and a pawn. Now, the students try to figure out the value of the pawn. And the way they do that is they try different numbers. So for example, we also tell the students that another name for the blue pawn is x. So for example, let's say that x is equal to 3. And let's see if that works out. If x is 3, I have 3 and 3 is 6 and 2 is 8. And on that side, 8 and 3 is 11. So we place a slash sign over the equal sign to show both sides are not the same. So let's try x equals to 4. 4 and 4 is 8 and 2 is 10. 8 and 4 is 12. And it doesn't work. Okay, on your text chat panel, do you know what number would work? The students will try different numbers until they find the value that does work. What value of the pawn will make both sides equal? That's okay, viewer 5. You could just tell me your name. That would be fine. Okay, so let's see if 6 works. If x is equal to 6, I have 6 and 6 is 12 and 2 is 14. 8 and 6 is 14, so 14 is equal to 14. Okay, so in lesson number 1 then, in lesson number 1, the students try different values for the pawn until they find the value that makes both sides equal. In lesson 1, they learn that the pawn has a fixed value in any given problem, that both sides of the scale must have the same value, and the name or value of the pawn is X. So that's lesson 1. The instructional component takes maybe 10 minutes, and then the worksheet will take another 15 minutes or so. Okay, now in lesson 2, the students are now exposed to an equation such as this. So we need to help them out. So in lesson 2, we say to the students, okay, you don't see me. Okay, let me share my screen here. In lesson 2, we say to the students, okay, boys and girls, we know that X is another name for the pawn. Since it says 3 X's, let's place 3 blue pawns on the scale. The symbol plus means that we have to add or place something on the scale. Since it says 1, not 1x, but 1, let's place a cube with the number 1. On the right side, it says x, so we need a blue pawn, plus 7, so we need a 7 cube. Okay, so each lesson of hands-on equations has only one new concept. The new concept in lesson 2 is how to go from the abstract equation to the concrete representation. At this point, the students try different values for the pawn until they find the value that works. Would you text chat the answer if you know what it is? What value of the pawn will make both sides equal? Okay, it looks like I'm seeing the answer of 3. Is that for this one or the prior one? 3. Okay, let's try 3. We have 3, 6, 9, and 1 is 10. 3 and 7 is 10. Okay, very good. Ashley is joining us. Okay. Okay, now in lesson 3, so here I need your help. We need to set up 4x plus 2 is equal to 3x plus 9. So let me do that over here. Okay. So I already have the 4x's plus 2 set up. Would someone tell me would you text chat please, what do I need to do on the right to set up the rest of this equation? Please text chat your response. I need to set up 3x plus 9. How would I do that? Okay, on the left we have 4x plus 2. Tell me how many pawns to set up, please. 3 pawns and a number 9. Okay, so let me place 3 pawns. 1x, 2x, 3x, and a number 9. Okay, so this then is the setup for this equation. Now, at this point, what we normally do is we say to students, okay, boys and girls, I'll give you 1 minute. See if you can find the value of the pawn. And usually in 1 minute, by trial and error, unless you're lucky, you're not going to get it. So at that point, we say to the students, would you like to learn an easier way to get the answer? And of course, they say yes. So then we introduce the concept of a legal move, that if we remove the same value from both sides of a balanced system, the system remains in balance. And we use both hands at the same time to do that. So we can remove another pawn from each side, and we can do that a third time. So notice that we have now simplified the equation, and we have a much simpler equation. On this side, we have a weight of 9. On this side of weight of 2, would you please text chat the value of the pawn? Well, what must the pawn be? The pawn must be 7, because 7 plus 2 is 9. So notice how in a few seconds we were able to solve this equation using these pieces. Now to do the check, we go back to the original physical setup. The students at this point are not ready to do the check abstractly. So we go back to the original setup. And if each x is 7, we have 7, 14, 21, 28, and 2 is 30. And on this side, we have 7, 14, 21, and 9 is 30. So both sides have the same value, okay? So in lesson 3, the students learned that they can perform legal moves with the pawns. Okay? Now, on the teacher demonstration scale, if you are a student in the class, this is what you would be seeing. The teacher is behind the scale. So you're seeing 4x plus 2 equals 3x plus 9. This is on the student, this equation is different? No. Okay, this is the student setup. Notice that the number cubes are facing upward toward the ceiling, so when you walk around, you can easily see the student setup. When we do the legal move, we use both hands at the same time. Okay, here you see the legal move being performed. And by using both hands at the same time, of course, the students are keeping track of what they're doing and then maintaining the equality at each step. On the student setup, the legal move can be done by moving the pawns down. And once they have the value for x, in order to check, first they clear the scale. I didn't do that here. First, they clear the scale to do the check. They put everything back up, and then they see that both sides have the same value. So in hands-on equations, we set up the problem using pawns and cubes. We use legal moves to solve for the unknown. We clear the scale, and we reset the scale to conduct the check. Okay, would you text chat okay if you think you're with me so far? Do you see the general approach that we take in this program? Okay, so that's lesson 3. Now, I don't know if I need to tell you, but there are many students in the 6th, 7th, 8th, and even 9th grade that cannot solve a simple equation such as this because they try to memorize procedures, not knowing what these symbols mean, and they get into trouble. And here, in just 3 lessons, the students can understand what it is that they are doing. There's a good deal of research that shows the value of gestures in improving mathematics learning. And the gesture that we showed is the removing a pawn from each side. So in mathematics, we have a principle called the subtraction property of equality. And that principle is what we called a legal move. Now, normally in school, very often the teachers will say, whatever you do to one side, you must do to the other. And we wonder why students don't solve the equations. Well, one reason is that since the students don't know what these symbols mean, notice what this student did. I don't know if it is she or he, don't remember, she took away a 2 value from each side. She's not aware that this plus 2 is a constant, this is a coefficient, they have different meanings, but whatever you do to one side, you do to the other. So notice you start doing things you're not supposed to do. So in hands-on equations, we're more particular. We say we may remove the same number of blue pawns from each side. We may remove the same cube value. Okay, now let's go to lesson number 5. So this one, I'm going to do it here. First, we begin with 5 pawns for 5x. What do you want me to do next? Would you tell me what you want me to do next? Notice that's the first time we're seeing that symbol today. Tell me, text chat, please. What shall I do at this point? Over here, what shall I do? Suggestion? It doesn't say 5x plus 3x. It says to subtract 3x. So what we're going to do is we're going to take away 3 of them. Then it says plus 2, so we're going to add a 2 cubed. And on the right, we have x plus 5, okay? So this then is the setup for equation number 5. From here, we know how to solve. We could do legal moves. But what I want to point out is that very often students will do this step immediately without the intervening step. In other words, they'll realize that since this is 5 pawns, take away 3 pawns, they'll mentally put down 2 pawns even though you did not teach them anything about combining like terms. Okay, so if I go into a classroom doing a guest lesson, invariably there'll be some students that will do this directly. So this is lesson 5. Now, in lesson 6, we start working with parentheses. And this figure here with the thumb is going to help us. So what we do is we tell the students, we give them a 4-step process. We say to the students, first, cover the number outside the parentheses. Okay, so can I cover it here? Okay, anyway, we cover the number outside the parentheses, and then we set up what's inside the parentheses. So let me do that. I'm going to set up an X and a 3. Then we uncover the number outside, and this 2 next to the parentheses tells us how many sets we need. So therefore, I need another set of X plus 3. And on the right side, I need a pawn and an 8. So this then is the setup for this problem. So this problem says twice X plus 3 equals X plus 8, and we know how to solve it. We could remove a pawn from each side. Actually, let me do that. Okay, before I do that, though, let me make this comment. Just as in lesson 5, after a few examples, instead of students setting this problem up in the form of X and 3 and X and 3, they're going to set it up in the form of 2 X's and a 6. Now, you have not, let's see, what did I do here? Okay, sorry about that. Now, you did not mention anything about the distributive property, but notice that what's happening. Since the students see here that twice X plus 3 are 2 X's and 2 3's, you're going to have some students who will do this on their own without your having mentioned the distributive property. Okay, now, in terms of solving it, let me solve it because I see that there's something I didn't show you. We could take away a blue pawn from each side. So let me take one from here and one from here. Now, in this problem, obviously, we don't require a student to do an additional step. It's obvious to the student that the pawn is 2 because 2 and 6 is 8. So, you know, our goal is not to have students do steps they don't need. However, if a student wanted to, they could subtract a 6 value from this side and a 6 value from this side. In other words, you can also work with the constants and subtract the same value from each side. Now, it says here, show video of Joseph. Okay, so you won't be able to hear him, so I'll be his voice. So in this video, Joseph, I think, is 6 years old. Okay, let's see. I'd like you to try to help me with this problem, please. Let's begin by setting up 2x's plus 1. What does this 2 outside the parentheses tells me? He says, do it again. So far he's setting up twice x plus 1 twice. All of that equals x plus 5. Do you see any legal moves? Okay, so he does that. Do you see another legal move we can perform? Okay, so 1 second. He said 1. So we said that this is a 5 value. This is a 1 value. This is a 5. This is a 1 and 1. How much is each of the pawns? So mentally, he saw that each pawn is 1. Write down x equals to 1. Would you reset the problem to do the check? And let's see if both sides have the same value. How much is this side? It says 6. Okay, so the check is an essential part of every problem. From lesson number 1, the students learn that every problem requires a check, okay? So hands-on equations is an algebraic learning environment in the sense that students pick up many concepts on their own. I mentioned combining like terms, the distributive property. For effective learning, we want to go from the concrete to the pictorial to the abstract. So the way the pictorial works is the students draw a picture of a balance scale. In this case, it's just a horizontal and vertical line. The x's are shaded triangles. The constants are cubes with numbers on them. Notice that this looks like a picture of the scale. And then the students use arrows to indicate their legal moves. Here I'm taking away 3 x's from each side. And with the cubes, I'm taking away 3 value from here. A 3 value from the 9 becomes a 6. And so that means that this x is equal to 6. And then we redraw the picture to do the check, okay? So if the students go through the first 6 lessons of hands-on equations with the manipulatives, they will easily, from our experience, be able to learn the pictorial notation. This is a page from the manual. All of the lessons are illustrated so that you can easily remind yourself of how the different problems are solved. Each lesson comes with a worksheet containing 10 examples. 4 are on the new work, and 6 reinforce the previous concepts that they have learned. Notice that every problem requires an X and a check. Research conducted by Dr. Larry Barber and myself had led to very interesting results. In this particular review of several studies from grades 4, 6, and 8, on the pre-test, the students did 30%, 50%, 60%. But notice that after the 6th lesson, all of the students did pretty much the same, between 85 and 92. This is after lesson 6 means with the manipulatives, and after lesson 7, they maintained the same scores. And this is using the pictorial notation. And the examples that were given are these examples. Okay, so the students so this is the retention test was given 3 weeks later. So 79% of the 8% of the students initially could answer this question correct. On the 3-week retention test with just the pictorial notation, 79% results. So those studies are available on our website. Maria Montessori spoke about the spontaneous leap from the concrete to the abstract. So I'd like to show you how now, first of all, here are a couple of pictures of children using the program. We encourage very much that the students go to the front of the room and demonstrate for their fellow students. Okay, here you have the kids working at their desk using their game pieces. Okay, so coming back to Maria Montessori, let's see how we would do this mentally. Let's imagine the X's are large bowling pins. Would you respond to my questions in the text chat? How many bowling pins do you see on the left? The X's are bowling pins. How many bowling pins on the left? Okay, how many bowling pins on the right? How many bowling pins can you subtract from both sides of the equation? How many bowling pins are you left with on the left side? So we're left with 2 bowling pins. What constant value can we subtract from both sides? 12. 12 from 18 is 6. 2 bowling pins are 6, so each X is 3. So notice how we can apply the methods we use concretely to solve this problem mentally. Okay, so The model that we use is very applicable to an abstract and written solution method. Okay, before we continue, it's a good time to take a break. What do you think so far? Do you think hands-on equations can be helpful to the students? Okay, so please text chat your responses. What do you like about what you've seen? Okay, the hands-on allows them to explore. Looks so great. I would like to use it with my 5th and 6th graders. I think hands-on equations will be very beneficial to my students. I like that it's truly hands-on. The need for initial concrete conceptual learning is met in spades with this program. Okay, good. Okay, so thank you for your feedback. So let's go on. We have a little more time here. So let me give you a taste of level 2. There are 3 levels to the program. What we did so far was focus on level 1. In level 2, we introduced the students to the white pawn, and its name is star. Stars are white like the stars in the night. If x is 2, star is a negative 2. In other words, if x means you find $2, star means you lose $2. If x means you lose $5, x means you find $5. X and star are opposites to each other. What do you think they work together? Would you text chat your response, please? How much would x plus star be if they're opposites of each other? It'd be 0. If you find $5 and then lose it, you're back to where you started. Okay, so x and star, if the blue and white pawn are on one side of the scale, the value is 0. Okay, let's look at lesson 10. We need a new legal move, so let's do that here. Lesson 10. Okay, 1 second. So I'm going to level 2, and I'm going to lesson 10. Okay, so I have 3x, 1x, 2x, 3x plus star equals to x plus 4. Okay, we have a new legal move here. Would someone suggest what the new legal move is, please? Please text chat your response. What would be the new legal move we can perform here? Do you see it? Remove 1 blue and 1 white pawn from the same side. Okay, so the new legal move is this. We may remove a pair of opposites provided they're on the same side of the equation since they have a value of 0. Okay, so that's the new legal move. And now we could solve it by taking another blue pawn from each side. And so we see that x is equal to 4. Now, once we know that x is 4, then by definition, star is a negative 4 because they're opposites of each other. And to do the check, we go back to the original setup. We have 3x plus star equals x plus 4. Now, in doing the check, there are 2 approaches that students can use. Since x is 4, we could say 4, 8, 12, 8, because this is losing 4, and 4 and 4 is 8. So the check is 8 equals 8. Another approach that students can use for doing the check is, since this pair is 0, we can just ignore it. And so the check is 8 is equal to 8. Okay, let me go on to lesson 11. Okay, now lesson 11 is very interesting. You have 2x equal to star plus 6. So the first question that we need to know, I need a response from you. is this a legal move? Yes or no? Please text chat your response. Did I just perform a legal move? I did not, because they're not worth the same. Okay? Okay, so going back to the last problem, the check is always done in the original physical setup. So you need to keep all the pieces on the scale. So in the last problem, you need to keep all the pieces on the scale. So let me go back. I can do that very quickly. So if all the pieces on the scale, to do the check, we always go back to the original physical setup. So this is the original physical setup. So therefore, if you evaluate this, you get 4, 8, 12, 8. You don't get 4. It's only in illegal moves that you remove the pieces. Okay, so the check is always done with the original problem setup. Okay? All right, let me go on to this equation here, because as you just said, it's not going to be, it will not be legal to take away a blue pawn from this side and a white pawn from that side. To be honest with you, if finding was the same as losing, some of us would be very rich from the stock market, okay? But unfortunately, it's not the same thing. Okay, so we need a new legal move. Do we have a suggestion, please? A new legal move. Add a white to both sides. Okay, good. Okay, that will help. That will help. But let me take your idea and modify it slightly. Instead of adding a white to both sides, let me add a blue to both sides. So since I'm adding the same value to both sides, that's the addition property of equality. I'm maintaining the balance. And now notice what I can do. I can remove a pair of opposites. So since 3 x's are 6, that means that x is equal to 2. And now we know that star is the opposite, so that would be -2. And let's do the check to see if it works. 2x equal to star plus 6. If x is 2, on this side I have 4. And on this side I have 6 lose 2, which is 4. So the check to this problem will be 4 is equal to 4. Okay, are you all together with the first legal move? We may always add the same value to both sides of the equation. We can add a blue pawn to both sides. Now, if we add a white pawn to both sides, you could solve it the same way. Okay, let me do that. Let's see what happens if you add a white pawn to each side. Okay, I have a white pawn here and a white pawn here. So I'm going to add them to both sides. What can I do now? Who sees a suggestion? I've added a white pawn to each side. What would you do next? You could use the same idea you did a few minutes ago, and that is you can remove this blue with this white pawn, right? Let's do that. So this one is removed, and this one is removed. What would you like to do now? You could do it again. You could add a white pawn to this side and a white pawn to that side. Let's do that. And again, you could remove a pair of opposites. Now, how much is this left side worth? You don't want to leave it blank. You need to put a 0 here. So notice that if this side is 0 and if the red cube is a 6, if you do it this way, each white, you're solving for the white pawn. What would each white pawn have to be to go from 6 to 0 in 3 steps? Each white pawn would be a -2. So this is a little more difficult, but it's not impossible. Okay, 6, lose 2 is 4, lose 2 is 2, lose 2 is 0. But the simpler approach was the approach we showed you earlier. Okay, let me reset the problem one more time. I want to show you a second approach that students learn for solving this problem. And that is, we already mentioned that a blue or white pawn have a zero value. So another legal move is that we can always add a zero value to either side. So let's add a zero value here. And now we can remove a white pawn from each side. Okay, so the children love that legal move. It's called adding a convenient zero. So let me show it to you one more time. In order to isolate the number cube, we want to eliminate the white pawn. The way we're going to do that is by adding a blue and a white pawn to the other side, because I'm only adding a zero value. And now I can remove a white pawn from each side, and I see that x is equal to 2. Okay? So that gives you an introduction to level 2. And notice that this legal move is used with one hand, since the blue and white pawn are taken from the same side of the equation. Okay, in order to begin wrapping up the webinar, let me give you a taste of how we solve word problems. We actually offer a full-day workshop, which will include age, distance problems, and so on. But let me at least solve one or two of you to give you an idea. Okay, 5 times K's age increased by 2 is the same as twice her age increased by 11. How old is K? So I would say that with hands-on equations, your students beginning in the 4th and 5th grade will be able to solve this problem algebraically. So what we're going to do is the first step is very similar to what we do normally, and that is we're going to say let on be K's age. In other words, we need to represent the unknown somehow. So K's age is the point. Now, the problem says 5 times K's age. So what do you think? Would 5 times K's age, would that be 5 pawns, or would that be a 5 cube with a pawn next to it? How would you represent 5 times K's age? Would it be 5 pawns, or, okay, I'm getting 5 pawns. So this is K's age 1 time, 2 times, 3 times, 4 times, 5 times. This is 5 times K's age, and you actually see her age 5 times. Increased by 2 is going to be the same as twice her age increased by 11. Now remember, these cubes are weights, so you don't want to use a 1 and a 1. That would be 2. Weight of 11 would be a 10 and a 1. So at this point, we can solve using our legal moves. Let's remove 2 blue pawns from this side and 2 blue pawns from that side. Let's remove a 2 value from that side. A 2 value from the 11 gives you a 9. And so we see that each pawn is equal to 3, but we're still not done because we haven't answered the problem. How old is K? So let's answer it. K's age is 3, and let's see if that makes sense or not. K's age is 3. 5 times K's age, that would be 15. Increased by 2, that would be 17. And that's supposed to be the same as twice K's age. Twice 3 is 6. Increased by 11 is 17. So we see that both sides have the same value. And so K's age is 3. Okay? So that's the general idea that we use in solving verbal problems. We won't have a chance to finish this one, but I can at least set it up for you. We have 3 consecutive numbers. So if the first number is a pawn, how would you represent the number after that, the next consecutive number after pawn? What would it be? You want the number that follows a pawn. Okay, so pawn represents any number. It would be, using pawns, it would be a pawn and a 1 cube. And the next consecutive number would be a pawn and a 2 cube, okay? And then to set it up, you would just, well, let me try to do it here. It says the last of 3 consecutive numbers. So that means we have a pawn and a 2. The last of 3 consecutive numbers, that's a pawn 2, increased by 10. So I'm going to increase by 10. Is equal to the sum of the first 2 consecutive numbers. Well, that's this one and this one, is equal to a pawn and then pawn and 1, okay? That would be the setup, and then you would solve. So you see that how the hands-on equations lends itself to these problems. Okay. So I trust that this webinar has been of value to you, as you noted earlier. Available materials for home use, we have a home packet. For the classroom, we have class sets of materials. We have verbal problems books. This one is an introductory workbook. This one has 350 word problems. We also have apps for iOS, Android, and Kindle.